Welcome to our last chapter of the semester on the Cenozoic era. Look at this. Look at this time scale. Here we are. We have 1.4% of Earth's history left to talk about, and it's awesome. Let's look at the geologic time scale first. So, the Cenozoic, because we know so much about it, because it's so new, is subdivided many, many times. So, you can see that the Cenozoic era is subdivided into three periods. So the first is the Paleogene, right? Like the Cretaceous, Paleogene, or Paleocene extinction. There it is. And then that's followed by the Neogene, which is followed by the Quaternary. So Quaternary means fourth. These two periods used to be linked, and they were called collectively the Tertiary, but the Tertiary is no more. Rest in peace, Tertiary. So periods are subdivided into what are called epochs. So the Paleogene epoch is subdivided into the Paleocene, the Eocene, and this is where I did my master's work right here at the Paleocene-Eocene transition on a really rapid global warming event and how it impacted the oceans and the acidity in the oceans. So that's just a fun aside. But the last epoch in the Paleogene is the Oligocene. After that, the Neogene starts, and you have the Miocene and the Pliocene. And then after that, we're really talking about modern history, like 1.8 million years ago to the present, and that's the Pleistocene, the time period when lots of North America was covered by glaciers. And then the modern, which is called the Holocene. There's plenty of interesting debate about whether or not we are in a new epoch that has been termed the Anthropocene. And there's lots of debate about where to put the base of the Anthropocene. Anthropocene means like the age of man, basically, or the age of humans. But I do think it means man. And it's a big question about whether we put it at the base of the Industrial Revolution or when humans began farming. But all of this is to say that there's a lot of funny words that you will be needing to know for your final exam, because you will be doing a section on the geologic timescale, just like always. So I invite you to come up with more creative, I think these are called anagrams, where you take the first letter of a word and use that to write a sentence so that you can remember it. Like for the epics, pink elephants on Mars play pretty hard, or people earning 1 million pesos pay heavily. Sometimes, honestly, when you're doing geology and there's this many weird words, it is super helpful to come up with some fun way to remember it. Regardless, the Cenozoic is known as the age of mammals. So as you recall, the end of the Mesozoic, big old extinction, and the world is dark and the world is cold, and the organisms that are going to live through that are small and warm-blooded, and they don't need as much food, really, because they're so small, and warm-blooded because it's cold. So we make it through, we do okay. There are a couple really cool things that happen in the Cenozoic, and so even though this is a small chunk of Earth's history, we know a lot about it, and there's cool stuff that happens. So we'll talk about tectonics, especially in the western United States, which is the sort of active margin in the Mesozoic and the Cenozoic eras. And then a lot of the tectonic changes end up leading to ocean circulation changes, which play really heavily into the climate changes that we observe in the Cenozoic era. So without further ado, let's talk about how tectonic changes can lead to climate changes. I love this section of the class, I'm not going to lie. So one of the things that happens in the Cenozoic is the isolation of Antarctica. So here's a paleogeographic map where the South Pole is sort of centered here. And you can see Antarctica connected to South America still 40 million years ago. So what happens is as South America continues to drift north, is eventually you have the isolation of Antarctica. And it creates a very strong current that whirls around Antarctica today. It's a surface current known as the west wind drift, because you can see it flows kind of from west to east. And what the west wind drift does is it basically isolates Antarctica, because it's not just an ocean surface water mass, but it's also an air mass. And it swirls around Antarctica, and what it does is it isolates Antarctica, and it stops any heat from being delivered to Antarctica from the more equatorial regions. And so as soon as we see the geographic isolation of Antarctica because of the tectonic motion of South America, we start to see the development of ice sheets in Antarctica about 34 million years ago. And this totally isolates Antarctica. It is cold and alone for the last 34 million years. And even though it's a desert, it has the most extensive ice sheets on the Earth. This is technically a desert because it gets less than 10 centimeters of precipitation in a year because it's so cold. Other cool things that happen are a little closer to home. Up to 5 million years ago, you could swim from the Pacific Ocean into the Atlantic Ocean. Isn't that cool? The Central America had not really risen up above sea level. And so 10 million years ago, this is the circulation system that you see in the surface waters. Well, about 5 million years ago, that changes. And that has important impacts on climate in the northern hemisphere. So just for funsies, just so you know, the way that we can tell that there are changes in ocean circulation is we actually look at the neodymium isotopes in fish scales. They basically tell you how old the water mass is that the fish are living in when they're growing their scales. It's cool. One of my friends from grad school ended up doing it and studying it, and now she's like the chair of one of the coolest geology departments in the country at Texas A&M in College Station. So, good stuff. Neodymium isotopes, folks. It's good stuff. So what this does, though, is it develops this current called the Gulf Stream. And the Gulf Stream impacts our weather in New York State, but it rings around the Caribbean, and it takes this warm Caribbean water and it delivers it closer to the poles. So here is the North Atlantic Current. The Gulf Stream is a portion of this. So it's a very fast current as well. It's one of the fastest. I think there's only one other current that's faster than the Gulf Stream in the world's oceans, and that's off the coast of Japan. It's called the Kuroshio Current. But what the important climate implication is here of the Gulf Stream is that it takes this warm water from the equator and it carries it across the Atlantic Ocean, and it warms and it brings moisture. So when you think about London, for example, in the United Kingdom, it's often associated with fog, and that's because you have this warm air interacting with the cold Arctic air here, and it creates this cool fog. The ice buildup that begins in Northern Europe begins about 2.7 million years ago, and that's because we start to bring precipitation or more precipitation to this portion of the world. And why that matters is because it ends up create that moisture, and that interaction between air masses ends up leading to the generation of 4 major ice ages in North America. And so what we call these in North America are the youngest ice ages called the Wisconsin glaciation, then the Illinoisan, the Kansan, and the Nebraskan glaciation. These words that are in lowercase, those are the warm interglacial periods that go in between the glacial periods. In Europe, these are called the alpine regions, and so it's a little bit different. And here's the years before present. So you can see that the Wisconsin glaciation ended about 10,000 years ago, but the Nebraskan began at the very beginning of the Pleistocene about 1.8 million years ago. So basically, this salty water, which was extra salty because you have high evaporation rates in the tropics, so you have this salty water. It brings the missing ingredient up into the North Sea here. It brings in moisture, so it's always cold in the Arctic and the North Sea, but in order to grow ice, you need both cold and water. And so this intensified Gulf Stream, which was intensified because it was cold, really cold here and really hot here, led to the buildup, ironically, of ice in Greenland and Northern Europe, which then led to those 4 ice ages. So the ice ages in North America led to the creation of the Great Lakes from erosion of pre-existing rivers. So I'm going to play a short film for you after I go through this diagram, and I'll tell you a quick story about that. So here are the outlines of the Great Lakes. You can't see Lake Erie here, but everything else is outlined. And here you have the flowing of the Laurentide ice sheet. It's called Laurentide because it went over Laurentia, of course, and it flowed south. And what it did was there were pre-existing rivers that were widened and deepened through glacial scouring and erosion. As that ice traveled, further south, and then when that ice melted, and so they call it ice receding, but it's not like the ice is doing anything but still moving down. It's just melting faster than it's moving down when it's receding. So you have the creation of the Great Lakes. The Great Lakes also change direction several times. Currently, they flow north out into the St. Lawrence Seaway and then out into the Atlantic Ocean. But there were times that it flowed down the Mississippi River. There's another time that it flowed through the Mohawk River and emptied into the Hudson Bay, or not Hudson Bay, but into the Hudson River and then down into the Atlantic Ocean as well. So there's a story behind this video I'm going to show you. My very first semester...
Watch the Oscars live on ABC, YouTube TV.
My very first semester teaching at MCC, oh good, there's more. Where's the volume? I had about 10, 12 minutes left in a class, and I needed something to fill my class time with. And our lab tech, Judy Hill, was like, oh, we have this great video on how the Great Lakes rose and fell, and you should totally use it in your class. And I was like, wow, that sounds awesome. And so without watching the video, I put it in and played it for my class. And I'm not gonna lie, it felt like I was new teacher hazed. But here is the video from the National Film Board of Canada about how the Great Lakes rose and fell. And I want you to know there's yodeling involved and square dance music and all sorts of, and there's beatnik music. It's fantastic. So I'm gonna shut up and let you watch this, but I might interject a little.
Now listen to me, people. I'll tell you what I found. I found the changes, oh those changes, keep the world going round. Yesterday, today, and when you wake up next morning. Long before the inland waters were traveled by a man, the Great Lakes were being created by the glaciers on the land.
Watch the Oscars live on ABC with YouTube TV. Try it free.
Only pay for what you need with Liberty Mutual. I just said that.
And the lakes still are forming, all changing one by one. Yes, they ask us with their beauty, what things are to come.
So this was the first time when I was watching this that it occurred to me that this entire video might be in song. And it is!
If you travel to the Great Lakes, 5 jewels neath the sun, you'd learn enough about those changes to satisfy anyone. You must be told again, the Great Lakes haven't always been. So look about you carefully and realize that what you see will not remain, will always change. And if you you could just leave today and travel back to yesterday, would what you see still be the same? Would what you see still be the same? 10,000 years ago today, the glaciers were going away. The lakes did remain. The lakes which always change. But if you could leave yesterday, travel back another day, would what you see still be the same? Would what you see still be the same?
So this is meant to illustrate different pulses of glaciation as we move back from the Wisconsin to the Illinois and
Now,
Kansas
ain't
and
that
so on
nice?
and so forth.
You're up on ice, a mile thick and moving slow.
And there's your warm period.
Now take your partner by the hair, hold her hand and form a square. I'll tell a story as we go, but don't forget to do-si-do, don't let go.
So there's your rivers.
Long time ago in olden days, the Great Lakes started in this place. They started quiet, they started slow, but watch and see the Great Lakes grow. Alaman left. Then one day the Ice Age came, lots of snow, not much rain. The weight of the ice made the land go down, scraped out a hole in the middle of the ground. Alaman right. The rock did scrape, the ice did move.
So this
Pretty
is called
soon,
basal
I'll tell you the
slip,
truth,
where
everyone was
there's
beating
grinding
time
against
to
the base of the
old square dance
glacier
and 2-4 time,
to the rock
do-si-do.
below.
Then one day, an eventful day, the sun came out, decided to play, and after a while decided to stay, and up and melted the ice away. Easy now, hold your partner. When the sun came out that day, the mighty glacier moved away. The consequences they did make the first and genuine Great Lake. Now this story happened again and again. Last time it happened was way back when, 10,000 years ago today. The very last glacier went away, bye-bye. Now the water coming in has to go somehow, and those days weren't the same as now. The water then was draining north, and nowadays it all goes south. How come? How come? Now swing your partner round and round, bow to your partner, it's all over now.
So this next part is just going to illustrate how as the Great Lakes emptied out of different rivers, those levels of the water would change dramatically.
When the weight of the glacier moved away, the land did spring back up again and cut off the flow of the water north and made it go instead to the south.
So there's some isostatic rebound that results in changes in water flow.
When you travel on the water and you think it's going fine, just remember like a tennis ball through time. When you travel the Great Lake waters, you can see far and wide
Erratics, glacial scouring,
the traces
striations,
of that glacier on its
eskers,
prehistoric ride.
it's either an esker or a moraine, drumlins, or drumlins,
As you travel on the water, which the ancient ice age planned, just remember there are changes which are also made by man, and the water.
I'm gonna pause it there because the rest of it is kind of depressing. It's really all about pollution and urbanization and how that impacts the water. But anyway, rise and follow the Great Lakes if you want to watch the depressing end to it, or you want to show your family. It's a catchy tune. You'll find yourself singing this later. Anywho, that's the end of different tectonic changes that influence climate change in the Cenozoic. Our next lesson will be on tectonics and what some of the modern landforms that were created in the Cenozoic.